everybody, welcome to our first video for STEM Maths topic 3. This is looking at rates and ratios. So the learning intentions for today's lessons are that by the end of this you'll be able to convert between fractions and ratios, and also that you can use a ratio to calculate some required quantity if the amount of one of those things is already supplied. So by the end of this lesson we'll do a quick recap and we'll make sure that we know how to do this. Opening question for you is, what is a ratio? So I want you to have a think about, if you were to speak to the person next to you, I want you to explain to them in your words, what is a ratio, and compare your answers with your partner. Then I want you to think about, when do we actually use ratios? What's an example of a time or a place that we might see one? And see how many real world examples you can come up with for that point. So pause the video, have a quick chat with your partner, and then we'll come back to it. So looking at ratios now, a ratio is really just another way of expressing a fraction or representing a fraction. Just as we would say that 1 on 2 or a half is a fraction, it also means that you have one part out of 2 in total. So it's kind of exactly the same. If something was given as a ratio, we would say a 1 to 4. That's how we read it with that semicolon. So this means for every one of something, we also need 4 of the other to balance it, because that is the ratio. Just like if we changed a fraction, here we said we had 1 out of 2, I could change that and say, well, if I had 2 of the top, I have to have 4 of the bottom to still balance that fraction to keep it the same. And a ratio is exactly the same. A 1 to 4 could be changed to a 2 to 8, could be changed to a 3 to 12, so on and so forth. We can change that ratio depending on what we have. You could also go backwards and say it's a 0.5 to 2, and that's okay in ratios. In fractions it's a little bit weird to do that, but in ratios sometimes that does make sense. On the other hand, if we had something like a 2 to 1 ratio, normally we wouldn't see this as a fraction because it just means 2. 2 on 1 is 2. But in a ratio, 2 to 1 means that we need 2 of this first thing for every 1 of the second. So it's just flipped the quantity of the things that we need, from less of the first to more of the first. Question for you, if I was mixing concrete and the concrete instructions said that I need a proportion of 3 to 1 sand to cement, so it's always the first thing listed is the first ratio, second thing is the second ratio. This means we need 3 amounts of sand to 1 amount of cement. If you had 3 bags of cement, how many bags of sand would you need? So think about that, jot down an answer, and I'll give you a solution in a minute. So let's have a look. So here we needed 3 to 1 sand to cement, whereas now you said you had 3 of cement, so I've tripled that one. I would need 9 times, or 9 bags of sand in this case, to balance the ratio. Now we're looking at simplifying ratios. So just like a fraction, as I said before, we can simplify it using common multiples and factors. Just as we can change 2 on 6 as a fraction into 1 on 3, we can simplify a ratio, so 2 to 8 becomes 1 to 4. It's exactly the same ratio, we've just factorized it down. If I was mixing this, it doesn't matter if I go a 2 to 8 or a 1 to 4, the balance is still the same. What I want you to do is have a bit of a practice in this game. So this is on Cool Math Games. If you go to this link, I'll link it in the Classcraft as well. But I want you, there's different levels, I want you to spend about 5-10 minutes playing this game, and it's a good way to practice this ratio conversion under pressure. So here it says, if you had 4 to 6, what ratio does that best represent? And you'd go, oh, in this case it's already got 4 on 6, so that's pretty easy. But it may have, say, like 2 to 3, and in this case 2 to 3 is already here, so bad examples. But sometimes you're going to actually have to simplify or factor out that ratio or the fraction to find which one it matches, and it can actually get quite difficult as you get to the higher levels. So about 10 minutes maximum just to get some practice on those ratios, and then we'll move on. So the success criteria check for today. The question I want you to ask yourself is, can I convert between fractions and ratios? And can I use a ratio to calculate the required quantity if the amount of one thing is supplied? Sort of like we saw with the concrete example, are you confident to do these accurately? If the answer is no to any of these, or you're not sure, go back and have a look at some of the examples we just did, speak to a partner near you, or come and ask myself, and I'll clarify that for you. If you're happy with that, mission accomplished, we're ready to move on.
Maximum effort.